Hi all, good morning. Today we can continue the session software engineering. These are the frequently asked questions about software engineering. First of all, what is software? Software is a collection of instructions that tell a computer how to work. Software is used to control a computer. There are different types of software that can run on a computer: system software, utility software, and application software. Computer programs and associated documentation. Software products may be developed for a particular customer or may be developed for a general market. And next question is, what are the attributes of good software? Good software should deliver the required functionality and maintainability and performance to the user and should be maintainable, dependable, and usable. Next is, what is software engineering? So for that, first of all, you have to know what is engineering. Engineering means it is an application of science, tools, and methods to find cost-effective solutions to the problem. The output should be cost-effective. Now let us see the definition of software engineering. It is defined as systematic, disciplined, and quantifiable approach for the development, operation, and maintenance of software. That you have to follow systematic, disciplined, and quantifiable approach for what are the products you are going to develop and what are the operations performing and maintenance. Then only you will be getting cost effective output. And next is fundamental software engineering activities are software specification, software development, software validation, and software evaluation. And next, what is the difference between software engineering and computer science? Computer science focuses on theory and fundamentals, whereas software engineering is concerned with the prac- practicalities of developing and delivering useful software. And next is difference between software engineering and system engineering. System engineering is concerned with all aspects of computer-based systems development, including hardware, software, and process engineering, where software engineering is part of this more general process. Software engineering deals with the designing and developing software of the highest quality, while systems engineering is the sub-discipline of engineering, which deals with the overall management of engineering projects during the life cycle. And next is, what are the key challenges facing software engineering? First, software quality and overrunning project timelines and unplanned and unforeseen technical faults. These are the key challenges facing software engineering. And next is, what are the cost of software engineering? Roughly 60% of software costs are development cost and 40% are testing cost. For custom software, evolution costs often exceed development costs. And next is, what are the best software engineering techniques and methods? Well, all software projects have to be professionally managed and developed. Different techniques are appropriate for different types of system. For example, games should always be developed using a series of prototypes, whereas safety critical control system require a complete and analyzable specification to be developed. You can't therefore say that one method is better than another. And the next is, what differences has the web made to software engineering? The web has led to the availability of software services and the possibility of developing highly distributed service-based systems. Web-based systems development has led to important advances in programming language and software use. Web developers are mainly concerned with websites and web applications that run on internet browsers, while software developers are more focused on computer programs for desktop and mobile devices. And next is software quality attributes are features that facilitate the measurement of performance of a software product by software testing professionals and include attributes such as availability, correctness, reliability, and also maintainability, testability. Characteristics of software is developed or engineered. It is not a manufactured. And software does not wear out. And next is software is custom built. These are the characteristics of a software. And next, these are the essential attributes of a good software. Product characteristics are maintainability, dependability and security, efficiency and acceptability. In maintainability, a good software must evolve with changing requirements. And in security, a good software must be secure. It should not cause physical or economic damage in the event of a system failure. Unauthorized users must not be allowed to access to the software. Then efficiency, it means that perform its operations with minimal time and processing power. A good software uses the least amount of processing power and memory needed to achieve the desired result. And software must be acceptable to the type of users for which it is designed. This means that it must be understandable, usable, and compatible with other systems that they use. Software dependability include a range of characteristics including reliability, security, and safety. A good software then should deliver the required functionality and performance to the user and should be maintainable, dependable, and usable. Next is software engineering. Software engineering provides a standard procedure to design and develop a software. The term software engineering is the product of two words, software and engineering. Software is a collection of integrated programs, and software subsists of carefully organized instructions and code written by developers on any of various particular computer language. Computer programs and related documentations such as requirement, design model, and user manual. Engineering is the application of scientific and practical knowledge to invent, design, build, maintain, and improve framework, processes, etc. Software engineering is an engineering branch related to the evolution of software product using well-defined scientific principles, techniques, and procedures. The result of software engineering is an effective and reliable software product. Then, why is software engineering required? To manage large software and for more scalability and cost management and to manage the dynamic nature of software and for better quality management. And importance of software engineering include reduced complexity, minimize software cost and effectiveness, reliable software, decreased time, and handling big project. Reduces complexity means big software is always complicated and challenging to progress. Software engineering has a great solution to reduce the complication of any project. Software engineering divides big problems into various small issues and then starts solving each small issue one by one. All these small problems are solved independently to each other. And to minimize software cost means software need a lot of hard work and software engineers are highly paid experts. A lot of manpower is required to develop software with a large number of codes. But in software engineering, programmers project everything and decrease all those things that are not needed. In turn, the cost for software productions become less as compared to any software that does not use software engineering method. Reliable software, software should be secure. It means if you have delivered the software, then it should work for at least its given time. And if any bugs come in the software, the company is responsible for solving all these bugs. Because in software engineering, testing and maintenance are given, so there is no worry of its reliability. And next is effectiveness. Effectiveness comes if anything has made according to the standards. Software standards are the big target of companies to make it more effective. So software becomes more effective in the act with the help of software engineering. And handling big projects are not done in a couple of days and they need lots of patience, planning and management. And to invest 6 and 7 months of any company, it requires heaps of planning, direction, testing, and maintenance. No one can say that he has given 4 months of a company to the task and the project is still in its first stage because the company has provided many resources to the plan and it should be completed. So, to handle a big project without any problem, the company has to go for a software engineering method. And to decrease time, anything that is not made according to the project always wastes time. And if you are making great software, then you may need to run many codes to get the definitive running code. This is a very time consuming procedure, and if it is not well handled, then this can take a lot of time. So, if you are making your software according to the software engineering method, then it will decrease a lot of time. The features that good software engineers should possess are good technical knowledge of the project range, means domain knowledge, and good programming abilities, good communication skills. These skills comprise of oral, written, and interpersonal skills, and exposure to systematic methods, that is, familiarity with software engineering principles, and high motivation and sound knowledge of fundamentals of computer science, intelligence, ability to work in a team, discipline. And next is software process activities. The term software specifies to the set of computer programs, procedures, and associated documents, means flowchart, manuals, etc., that describe the program and how they are to be used. A software process is a set of activities and associated outcome that produce a software product. Software engineers mostly carry out these activities. These are four key process activities which are common to all software process. These activities are software specification, software development, software validation, and software evaluation. Software specification, the functionality of the software and constraints on its operation must be defined. And in software development, the software to meet the requirement must be produced. And in software validation, the software must be validated to ensure that it does what the customer wants. And in software evolution, the software must evolve to meet to meet changing client needs. അതായത് ക്ലൈൻറ്റ് നീഡ്സിന് അനുസരിച്ചിട്ട് സോഫ്റ്റ്വെയറിന് ചേഞ്ചസ് വരുത്തുന്നത്. ഓക്കെ, where the software is modified to reflect changing customer and market requirements. Software is more than programs. Any program is a subset of software and it becomes software only if documentation and operating procedures manuals are prepared. Actually, the software is a combination of program, documentation, and operating procedures. Program is a combination of source code and object code. Documentation consists of different type of manuals. Example of documentation manuals are data flow diagram, flow chart, ER diagrams, etc. And operating procedures consist of instructions to set up and use the software system and instructions on how react to the system failure. Example of operating system procedures manual is installation guide, beginner's guide, reference guide, and system administration guide, etc. And next is general issues that affect most software are heterogeneity, business and social change, security and trust, and skills. In heterogeneity, systems are increasingly essential to operate as distributed systems across networks, which include various types of computers and mobile devices. Software can be installed on cell phones as well as on general purpose computer. For older operating programs written in various programming languages, we also need to implement new applications. The goal here is to create strategies that are versatile enough to deal with this heterogeneity and construct dependable applications. Hence, increasingly, systems are required to operate as distributed system across network that include different type of computer and mobile device. And business and social change. As emerging economies grow and new innovations become available, business and society are evolving extremely rapidly. They need to be in a position to update their current software and create new software quickly. Many conventional software development approaches are time consuming, so it sometimes takes longer than expected to produce new system. They need to change so that the time taken for the program to provide value to its clients is decreased. And security and trust. Since software is intertwined with all facets of our lives, we need to be able to trust the software. This is especially true for remote software system, which are accessed via a web page or web service interface. We must ensure that unauthorized users are unable to target our application and that information is protected and secured. And the next is scales. The software must be built over a broad range of scales from very tiny embedded system in portable or wearable devices through the internet says a cloud-based framework that serves global population. Next is software engineering and the web. The web is now a platform for running application and organizations are increasingly developing web-based systems rather than local systems. Software engineers use the computer science background to create software products, including web based software as well as software designed for operating system. Cloud computing is an approach to the provision of computer services where applications run remotely on the cloud. Web software engineering. Software use is the dominant approach for constructing web based software. When building these systems, you think about how you can assemble them from pre-existing software component and system. A web developer specializes in web-based applications such as websites, e-commerce, and mobile development. Web-based systems should be developed and delivered incrementally, and user interfaces are constrained by the capabilities of web browsers. In front-end development, web developers create the client side of a website, and the back-end developer deals with business logic and database development. Web software engineering means software engineers use their computer science background to create software product, including web-based software as well as software designing for operating system. Web developers and software engineers both study programming and learn to write code. Web developers specifically focus on designing and creating websites, while software engineers develop computer programs or applications. These engineers determine how computer programs will work and oversee programmers as they write the code that ensure the program functions properly. Technologies such as AJAS allow rich interfaces to be created within a web browser, but are still difficult to use. Web forms with local scripting are more commonly used. Software engineering is an engineering discipline that is concerned with all aspects of software production. It provides a standard procedure to design and develop a software, and it is defined as systematic, disciplined, and quantifiable approach for the development, operation, and maintenance of a software. Essential software product attributes are maintainability, dependability, and security, efficiency, and acceptability. And high level activities of specification, development, validation, and evolution are the part of all software processes. And the fundamental notions of software engineering are universally applicable to all types of system development. And next session is software engineering ethics. Software engineering ethics is a type of professional ethics, and it involves wider responsibilities than simply the application of technical skills. Software engineers must behave in an honest and ethically responsible way if they are to be respected as professionals. And ethical behavior is more than simply upholding the law, but involves following a set of principles that are morally correct. Software engineering ethical issues are privacy, accuracy, property, effects on quality of life, are all issues that must be considered in developing and delivering computer software system. Next is software engineering ethics, issues of professional responsibility. Like other engineering disciplines, software engineering is carried out within a social and legal framework that limits the freedom of people working in that area. As a software engineer, you must accept that your job involves greater responsibilities than simply the application of technical skill. You must also behave in an ethical and morally responsible way if you are to be respected as a professional engineer. It goes without saying that you should uphold normal standard of honesty and integrity. And also you should not use your skills and abilities to behave in a dishonest way or in a way that will bring disrepute to the software engineering profession. However, there are areas where standards of acceptable behavior are not bound by laws, but by the more professional responsibility. Some of these are confidentiality, competence, computer abuse, intellectual property right. And the professional societies in the US have cooperated to produce a code of ethical practice. Software engineers shall commit themselves to making the analysis, specification, design, development, testing, and maintenance of software a beneficial and respected profession. In accordance with their commitment to the health, safety, and welfare of the public, software engineers shall adhere to the following principles such as public, client and employer, product, judgment, management, profession, colleagues, self. In public, software engineers shall act consistently with the public interest. And client and employer, software engineers shall act in a manner that is in the best interest of the client and employer consistent with the public interest. And software engineers shall ensure that the products and related modifications meet the highest professional standards possible. And software engineers shall maintain integrity and independence in the professional judgment. And software engineering managers, leaders shall subscribe to and promote an ethical approach to the management of software development and maintenance. And software engineers shall advance the integrity and reputation of the profession consistent with the public interest. And also, software engineers shall be fair to and supportive of their colleagues. And software engineers shall participate in lifelong learning regarding the practice of the profession and shall promote an ethical approach to the practice of the profession. And the next is disagreement in principle with the policies of senior management. Your employer acts in an unethical way and releases a safety critical system without finishing the testing of the system. And participation in the development of military weapons system or nuclear systems. Okay, thank you.